All right, hello everyone. I am Jason Falk with Hurco Applications. Joining us today, we have Mike Cope. He's going to be kind of moderating and watching our chat window through the other sessions that we've had. We have found that chat area has been a pretty busy section. So feel free, any questions you have through this to type them into that chat area. And at the end of the presentation, we will have a session there for question and answer. We are recording this. If any of you would like to see it in the future, you should receive an email showing you where to go get that. So we will go ahead and get started. Today we are going to be working on session 3, which is swept surface, and specifically working with swept surface on 2D geometry. We're not really intending on using today's session as a training for swept surface, but more how to adapt it to a very specific application. If any of you find that you would like a little bit more information on swept surface and how that works, if you go to our website and you look in our training area, I'll kind of walk through the steps here. If you go to our support tab and scroll down to the WinMax intro classes, the video section, this will take you into an area where we have a lot of videos that I know some of you have already worked through, which will walk you through a lot of our intro classes. But over on the side, we have this video categories area. If you go down and find webinars, which at least as we refer to them here, is just an online session, could be a meeting, could be a training class. You will see the online training sessions that we've been doing, a couple that we have here. And then down below, we have the WinMax 3D mold and swept surface webinar. I believe this was one of our original webinars, our first attempts at this kind of thing. And we had a few customers that really wanted a little bit more training on the 3D options on the machine. So we took that opportunity to put that together. We did record that session, and we've used it many times since. I will warn you, that one's probably about an hour and a half long, so a little bit longer than some of them we do. But it is a good tutorial on the 3D mold and swept surface options. So if you find yourself at the end of the presentation wanting a little bit more detail on the swept surface, just please refer to that. I will do a bit of an overview of swept surface, just for those of you that may not have used it before, but again, not a full training session. And I guess to start with, for those of you that may be viewing these quick training sessions for the first time, to kind of show you what we're working with, I am going to be using the WinMax desktop software. This is an option that, or a feature that Hurco sells, which is essentially the exact same software that's on your machine, just allows you to use it on a desktop PC. So you could potentially use this for training, go through, program up your parts, or even on the shop floor, so you can sit down at your desk, program where it's a little bit more comfortable, save that program off to a USB or a network drive, and then go use that out at your machine. So that's what we're going to utilize here. If any of you would like a trial version of this software, please let us know. At the end of this presentation, I will put up some contact information. And if you would like to either work along with some of those training videos, or maybe try some of the stuff we're doing in these quick training sessions, please let us know. We will get you what you need to get that up and running. So please let us know if you'd like to take advantage of that. So now I'm just going to jump right into it. We'll start with a quick overview of what swept surface is. And the best way to do that, I think, is to simply walk through a part that's already been created. So if we take a look at our graphics screen here, I have a part, nothing overly complicated, just a pocket. But if we start to look at this, you'll notice that we don't have straight walls here. We have some draft angle on these walls. So we'll walk through what we did in order to create that on the control. The easiest way to see or to manipulate the swept surface data block is through the review screen, especially if you've already created that data block. You'll notice that block 1 in this program is a swept surface block, and it is a pocket. Over in the sub blocks, it starts to differ a little bit from what you may be used to with your standard lines and arcs. You'll notice that under the sub block, it has an along contour, and then we have several segments that deal with that along contour. And then that one ends, and then we have a profile contour. So essentially, we have two different contours in one data block. What you're doing with swept surface is you're basically taking any 2D geometry and sweeping it along other 2D geometry to create 3D geometry. The best way I've ever heard to explain this actually came from Mike. I heard him explain it. I thought it was a perfect analogy, so I'm going to go ahead and use that. For those of you that may do any woodworking, if you're familiar with a wood router, just a standard wood router, you can put your router bit in, run it along the edge of your part to get a profile. We're going to use that analogy here to kind of explain swept surface. So let's say we're making a desk, and we've got the top of our desk created, and now we want to kind of break that top edge. You know, maybe we want to put a radius on it, or a chamfer, or maybe some kind of decorative design or profile. If we look at the swept surface block, that router bit that we're putting in that router, that is going to be the profile contour. That's the shape that we want to kind of drive around our surface, or in this case, the desk. The desk itself is going to be the along contour. You know, essentially, we're going to take that router bit, we're going to put it in our router, and then we're just going to run it right along the desk, and we're going to put that profile, or the shape in the router bit, all around the top of our desk. So essentially, we're taking our profile contour, or our router bit, and we're running that around our along contour, or in this case, the desk, in that little analogy. So that's the simplest way I found to describe that. So now we'll kind of walk through the data block and how that works. So you'll notice from the review screen here, you can jump into any one of these areas just by clicking on that area, or double clicking, or tapping on the machine. So if I want to go to my along contour, just double click on that. I am now in that along contour, and I'm just going to define the contour like any other lines and arcs geometry. If I go back to that review screen, same thing. If I go down to my profile contour, I can just double click on that, and now I am in that profile contour. So you're basically just defining two 2D geometries and driving one around the other to get 3D geometry. If I go into the swept surface block itself, you'll notice that there's a whole lot going on in this data block, and we're not going to hit on all these features. This is where that other training video would come in, but we're going to touch on a few. And the nice thing about the swept surface block is even the guys that use this on a daily basis, they probably rarely hit on the majority of these fields up here. A lot of them are used in very specific cases, so you get really used to knowing what you can just ignore here and what you have to deal with. At the top, the first thing that I'll point out is our type. If you're not in the review screen, this is where you switch between your profile or your along contour or the swept surface, which has all these parameters. So you can just use this drop down and then start to jump in to those profiles. And we'll show you how to do both of that here in the next few minutes. Now we've got something like, there are things that you're used to seeing, you know, like your Z start here, just tell it how much you want to start above the part. Looks like I may have missed that, so I'll go ahead and put that in. But where we're going to spend most of our time is down here in the bottom. For the most part, it's similar to what you have been seeing in any other data block. You will notice we have more options, or more tabs down here. We have a pocket roughing tab and a pocket finishing tab. The reason for these two additional tabs, and you can see we still have the other tabs that you're used to, is we are defining a surface that we want to cut here. Well, it's very common to then want to take that surface and also make a pocket out of it, like we have here. And if you are pocketing and surfacing, well, there's a good chance that you want to use a different tool for the roughing than you want to use, or I'm sorry, for the pocketing than you want to use on that surface. So if we take a look here in my roughing, which is my surface, what we're defining, I'm using a 1/2 inch ball end mill. If I go to my pocket roughing, I'm using a 1/2 inch flat end mill. So it just gives you the ability to kind of use different tooling for different features on this data block. You will also notice in the pocket area, when you select your milling type, we have a few more options in the pocket than we're used to. We have the island and boundary like we've always had, but now we also have the ability to make this single data block a boundary and an island at the same time. For example, let's say this pocket here, we've already got it as a boundary, so it tells it to remove all this material on the inside. If there was some more features to this, maybe we had a radius or a little pyramid, something like that out here, and we wanted this entire piece of geometry to be an island to something else, maybe like our stock size, something like that, you can make a swept surface block be both an island and a pocket boundary. So, and we do have some examples of that if anyone would like to see that. And then just your standard tabs over here. Because there are more tabs, you do have these arrows to kind of jump back and forth. So in this data block, we went ahead for my along contour, and let me do something to make this a little bit more visible. If I go into just my toolpath, we'll go into my XY view. If I go to my swept surface, I just want to see my along contour and jump into that, you'll notice, oops, sorry, I hit next block there, meant to hit next segment. So you'll notice this is nothing more than lines and arc segments. So if I draw this with only that along contour being displayed, you can see that this is the surface, or the along contour that we defined, just a square shape with some corner radiuses. If I go in and tell it I want to see just my profile contour, and I draw that, you'll see that the profile in this case is nothing more than just a tapered line. So essentially I'm taking this profile here and I am sweeping it along the first contour, or the along contour that I showed you just a second ago. You put both of those together and then you will get the surface that you intended to cut. So that is kind of the basics of the swept surface data block. We'll go into a little bit more detail on some of these features. So you can see there, that's how we would use this feature kind of more as it was intended to get a 3D geometry. Before we go on to the application I want to spend a little bit of time on today, there's one other thing I'd like to show you. And to do that, I created another program very similar to what we've done here. If I draw this, it looks very similar, just a pocket with some drafted walls. Where the difference comes in, if I look at this in my my XZ view and my YZ view, if I start jumping back and forth, you'll notice that there's different amounts of taper, there's different amounts of draft on these walls. I can show you how we accomplished that. To do that, in the swept surface data block, one of these parameters that you typically just kind of glance over is individual profiles. We have the option of yes or no here. I went ahead in this case and set that to yes. And you'll notice what that does for us is we still have the same long contour, but then we have a profile contour 1 and a profile contour 2. So now when you go in to define your profile contour, it's going to ask you what profile number you're dealing with. So for profile number 1, I just simply started at X0 and Z0, and I went down and I just threw some numbers in here so we could see the geometry, but I went down to 1 inch in Z and 1/4 inch over in X. If I go to my second profile contour, and again, you just give it the profile number here. I started at X0 and Z0, and if I go to my next segment, you see I just extended the X out a little bit. I went 350 thousandths here instead of the 250. I still went to the same Z depth, giving us just a slightly different angle. So I defined two different profiles, two different router bits, if you will. And then when I go into the along contour, for each segment, it's going to ask me which profile do I want to use. So for the segment 1, which is one of the straight walls, I just simply told it I wanted to use profile 1. When I go into segment 2, I'm telling it I want to use profile 2. It's like segment 3, I'm using 1 again, and profile 4, I'm using 2. So you just go in each segment and tell it which one of these profiles you want to use. And when you get done, you should have some geometry with different profiles on different segments of this along contour. This is the draft angle, I think, is probably one of the more common uses of this, but there are other applications where different profiles can come in really handy. And again, if you just kind of look at this from the side views, you can see that there are different draft angles on those walls. So that's another feature that's here I wanted to at least point out. We had some suggestions on mentioning that in the presentation, so I thought I would take a little time to bring that in. So that is the brief overview of what swept surface is. Again, if you need a little bit more on that, please go check out the previous video on the 3D mold and swept surface training session. But now let's put this to use in a slightly different way. And what we're going to do now, I have created a program, which I'm going to walk you through here in a second, is we are basically going to use the swept surface option, generally used for creating 3D surfaces, but we're going to utilize this in a 2D geometry conversationally. What this is going to allow us to do is to create a ramp style tool path. Back on before we had the swept surface option, there were a lot of times where I started creating a part where I really wanted to do the ramp style tool path on a odd shape, something like we have here. And I essentially just ended up going to a CAM system because I really wanted to do that ramp style. I'm a big fan of that style of cut. Many of you probably watched the first session where we went over helix. I use that a lot for round geometry, but I can't really use that for here because we have an odd shape. So once we were given the swept surface data block, it didn't take long before we tried it with a 2D surface to get this style of cut. So we'll show you how we do this. Before I start the program here, however, I'm going to attempt to show you a quick video. I went out and cut this part yesterday, and for those of you that may be questioning what's going on, I just wanted you to be able to see it, and then I'll kind of be able to talk about certain aspects of the motion as we're going here. So I'll go ahead and get this started. It may be a little laggy because of the connection here, so I'll kind of explain what's going on. And the first thing you're going to notice is when this starts cutting, you'll notice it takes a path or a pass around the top without moving Z. I actually started this about 20 thousandths above the part, just a little bit above. So the first thing it does, since we're going to be ramping down in, is it makes a pass at that Z start level where I started my profile contour at. So it's going to take a pass, a complete revolution around at that, and then it's going to start to drop in at whatever my step over is to cut this part. So we'll get it playing here. And I don't know if the volume's going to come through or not. But right now we're just simply taking that path or that pass over the top of this. I believe that's about where it started, so we should start ramping down into the part here. And now you can see it's starting to cut. So basically we're just doing a constant XYZ ramp tool path in this part. A couple of times when I like to use this, I guess one of the main times I like to use this is if I'm cutting a part and maybe my fixturing isn't quite as rigid as it could be, take for example this part here, I did mill a couple flats into the material, so I probably got a pretty decent hold on to it. But if my fixturing wasn't as rigid as maybe it should be, I like this style of motion because of rather than coming in and putting a lot of side load on, to take a cut, sit down and take another cut, I've got most of my pressure is going down in the Z axis. You can see here on the front of the part as we come in, I'm taking a pretty healthy width of cut there, but because I'm not just stepping down a large amount and then plunging in, I'm not getting a whole lot of excessive side pressure. So if your fixture isn't necessarily as rigid as it could be, this helps give you that pressure in the direction you would like, which is going down. Also, if you're doing extremely deep contours, maybe you have an inserted cutter and you're going to be going around the outside and you don't have a whole lot of flute length on your cutter. This is a nice way to get a nice, smooth, consistent surface finish all the way down that wall. You'll notice that there is no blend in and out. It is a constant ramping motion on that wall. So you should get a very nice surface finish with no transition witness marks when it's all said and done. Once we get to the end of this video, it should be just about there. Similar to what we did at the beginning, where it took a pass around the top at that constant Z level, it'll also do that at the end to make sure that we clean up that entire floor surface. The swept surface option will go ahead and do that for you. Nothing you have to do to make that happen. Just for reference, once we get going, this is a 5/8, a 0.625 end mill, and that stock there is roughly 2 1/4 diameter. It's not a very large part. And if the audio did come through on the video, you could hear that last pass did kind of equal out so that we weren't cutting anymore, just taking a pass around. So now let's go and show you how we created that data block. To do that, I'm just going to go into the desktop software. I'll just go ahead and take the block that we created, and I'm going to delete that out. So now we're left with just a blank program again. To get started, I'm going to go in, I'm going to go into my milling and create a swept surface data block. Now, just in an attempt to try to save a little bit of time here, I'm not going to go in and program that entire contour. I'm going to use our DXF option to be able to bring that in. So to do that, I've already loaded in the DXF file. So I'm just going to go in, tell it I want to create this contour, reverse the direction there. I'm going to accept that, and it tells me the milling data block was inserted in the program. So if I go to my review screen now, there's the swept surface block that I originally created, and here's the contour that I just used the DXF editor to pull in. So what I'm going to do here is I'm going to copy the contour block as it is now. I'm going to go into my multiple block functions, tell it I want to copy that block. I'm then going to highlight the swept surface block and then select paste. When I hit paste, because I'm sitting on a swept surface block, it's going to ask me, do I want to paste this block into the swept surface block? I'm going to say yes to this. And because there are two different contours I could potentially be loading in here, it's going to ask me, do you want to paste this into the swept surface along contour? If I say yes, becomes my along contour. If I say no, it'll just dump it off as the profile contour. So I'm going to go ahead and say yes to that. So our along contour has just been set. Got the 20 segments were added in that make up that outside geometry. So we've got a good start on this. I'm gonna go back. Actually, before I do, I'll delete this data block. Just use that to kind of simplify the creation here. I'll go into the swept surface block. I'm now going to set it to draw the profile and edit the profile contour. Now, I mentioned before that I started a little bit above the part, so I'm just going to tell it I want to start at X0 and Z. Let's do about 20 thou above our part. I'm then just going to go to my next segment and very simply give it a line segment. It's going to end at 0 and Z of -1 inch. So I just gave it a straight vertical line here. If we go back to the review screen, I've defined my along contour and I've defined my profile contour. Now all I need to do is go into the swept surface block itself, the main area, and kind of define what we want it to do here. So I'll come down here to the bottom. I'm going to tell it I want to start with tool 2, which is at that 5/8 or 0.625 end mill. And then in the cut direction, it's going to give us a couple options for how do we want to cut. We have one that's going to follow the contour, which basically means in this part here, it would cut in a Z motion. So it would plunge down the part and then come up and then plunge back down. Probably not something we want to do here. We also have normal to the contour, which would go around the outside of the contour, which is much better. It does give us the option here if we want to go bi-directional, so it'll go around and then come back, so it'll be reversing itself. But we have one better option here for this particular surface, and that's this spiral cut. If I choose this, this is going to give us that constant ramp tool path that I'm looking for. So we've got your standard speeds and feeds that you can set up here for whatever you like. And then over here, we have your step size. I'm going to tell it how much I want to drop. On the part we cut yesterday, I did 60 thou for my step size. So essentially on this particular part, every time it has gone around this thing once, it should have dropped 60 thou. Very similar to the lead if you were working in a helix. If you do want to take pec depths, you can do that. It doesn't work out real well for the application we're working with now, but on a standard surface, that is something you use quite a bit. So I'll go ahead and draw this. Oops. So I did get an error message saying my Z start is too low, which kind of makes sense. I started a little bit above my part, and again, I forgot to go give it a Z start. So I'll give it a value there. It wasn't liking that I was trying to go below where I wanted to start this ramp tool path at. So if I draw this, it looks like I've made one additional mistake here. It looks like we're cutting on the wrong side of that along contour. So if I go to my review screen, go into that along contour, you'll notice we have this option here for surface side. And it tells us in the conversational area, select right if the surface is to be cut to the right of the along contour, otherwise select left. So we are going to choose the left contour, or left side of that contour, and then we'll graph this again. So that looks like the part that we intend to cut. If I slow my graphic speed down a little bit, you can see there we've got that nice ramped tool path that we were going for. If I go into my graphic settings, and let's just say I look just at the tool path, I think if you look at it in the side view, zoom out a little bit, you'll notice that we've got this ramp. We have no transitions where it's just stepping down. Same thing in the YZ. So this is why we're going to get that nice smooth motion with the good surface finish. We're not going to have any transition where the machine is just plunging in Z. It's going to be a nice, smooth, consistent motion. And like I said at the beginning of this presentation, mostly preference, but I really do like that style of cut. That's why I use the helix option so much, and that's why I was so excited when we found that we could use the swept surface to get this style of cut. So I was no longer, tied to the cam system in order to get this type of tool path. So that is our topic for today, using the swept surface to generate 2D geometry. I'm sure if you guys have been to any trade shows, anything like that, you've probably seen us doing this. It's one of my, I guess, tools in my toolbox of things I like to do when programming on a Hurco control. So with that, we'll turn it over to Mike and see if there were any questions.
All right, Jason, can you hear me okay?
I can.
Okay. Yeah, we have a few. I've tried to answer a couple as we went here, but I wrote them down as well. The first one was on your very first example, the frame that you used with the tapered walls.
Okay.
The question was, are the two profiles blended at the intersections? So yeah, maybe
the answer there is
see it better.
Yeah. So I guess the answer there is yes and no. On this case here, they are. And you'll notice when I created this particular part, if I go take a look at the along contour, I added in blend arcs here. So if let me make this a little easier to see, I'm sorry. Go to the toolpath. So if we look at the XY view, I wanted to control those a little bit more. So I did add in the blend arcs. Now, because we are generating a surface, and if we think about what we've done here, we created another surface that's going to taper inward. As we work in towards that pocket, these radiuses are going to get smaller as we get towards the bottom because we're kind of collapsing in on ourselves. Likewise, if we had programmed it the opposite of that, we were getting larger with our surface, those radiuses would start to get a little bit bigger. You'll notice on the other part, the drafted pocket with different angles, I went a little bit different route with that. If you look at my along contour here, I left all the blend arcs out. I let the control determine how it wanted to blend those. Put my solid back on. It's going to be a subtle difference, but it is slightly different. But now the control is determining those blend moves. And the way it's doing that in the swept surface block is we've got this type of corners where you can set if you want them rounded, extended, or truncated. There's several examples of that in the 3D mold and swept surface training video that we mentioned earlier as well. But so it is doing the blending between those two surfaces, if that answers the questions.
Yeah, I think it probably did. The next one we had was on your little VM10 video where you were cutting the part. They asked if that could be done with a helix in lines and arcs.
Well,
explain why we couldn't.
You could do part of it. You could do, so let me switch back to that, which is the part we just programmed. You could program part of it, and I have in the past done a helix to rough in parts that are a little bit more rounded. So you could do that, and if you really wanted to, if someone was really determined to get this tool path, you could go in and program basically all this tool path. Go in and program each segment and give it a different Z end. It would force you that you'd have to go all the way down this thing. So, on this particular part, we have, looks like 20 segments, and there's probably about 20 different steps here that it worked its way down. So you would end up with something like 400 segment contour, but you could go in if you wanted to and program all this in lines and arcs and get the same type of motion. This is just a little easier way of doing it. If you wanted to use the helix, you could program these straight lines with lines and arcs, and then each of these radiuses you could use helix there as well. But at that point, since you're already doing the straight lines, you can just do about the same thing with an arc with a different Z endpoint.
Yeah, short answer being that this particular shape wouldn't be very good for helix.
Yeah, you could if you really wanted to put the effort in,
right.
But you're going to end up with a lot of time and something like that there.
Okay. The next one, actually I'll jump to one that was just put in because it kind of goes with what we're doing now. Will the finish pass spiral as well? So if you selected to spiral around the outside, will the finish pass automatically do that also?
Yes, it will. It'll basically kind of duplicate the same thing, just with removing with whatever stock allowance you have. You can see that when you go into your finish tab, it does give you another step size. So you could rough it out. Maybe I want a little nicer finish than what the 60 thou step size was giving me. I could come in and step it down in a finish pass, and it will do the ramp motion.
Okay. All right. The last question that was in the chat, at least up to this point, was someone was asking the difference between 3D mold and swept surface. So I think you mentioned that at the beginning, but you might cover that a little bit better.
Yeah, that's a good question. So 3D mold was our original 3D option on the machine, and basically that allows you to take any 2D geometry and revolve it about an axis, or you can even translate it in an axis. But that's about where that data block ends. So you can take a geometry, you can revolve it, or you can translate it, but that's about it. With swept surface, you can kind of do that same thing, but you're not locked to just one revolve or one translate. You can take that feature and run it around whatever contour you can dream up. So it just removes some of the limitations. Now, if you're doing a simple shape, maybe like a bowl or a dome, something like that, I still like to use the 3D mold for that, just because there's a few less options you have to deal with. So it's kind of a simplified version of swept surface, if that makes any sense.
Yeah, I think it does. Well, I'm watching the chat again here, and there's no new ones have come in. So that was the list of questions that we received.
Okay. Well, why don't we, I'm going to go ahead and end the recording here.